5.4, exponential and logarithmic equations. We will solve simple exponential and logarithmic equations, just like everything we do in this class is simple. Oh, and then we'll solve more complicated exponential equations, but they're still simple. And logarithmic, real life problems. Okay, I've talked about this before. Exponential and logarithms are inverses of one another. Okay, so just like, and I'll get back to this in just a second. So if I had x plus 4 equals 8, how do you get x by itself? Because subtraction is the inverse of addition, right? If I had 4y equals 16, how would you get y by itself? Divide, because division is the inverse of multiplication, okay? Logarithms and exponentials are inverses of one another. So how do you unlog something? You make it an exponent. How do you bring an exponent down? You take the logarithm of it, okay? So it's not a big deal. Two basic strategies for solving exponential logarithmic equations. First is based on one-to-one properties and was used to solve simple exponential logarithmic problems. The second is based on the inverse properties. A has to be greater than 0, but it can't be 1. And the following properties are true for all x and y for which log base a of x and log base a of y are defined. One-to-one properties. If a to the x is equal to a to the y, what must be true? X must equal y, right? You've used that in your homework, I think, or a property like it. So if I've got a to the 5th power and a to the x power, what's x? A to the 5th equals a to the x, means x equals what? 5, right? When the bases are the same, then the exponents have to be the same also. Log base a of x equals log base a of y if and only if x equals y. So those are the very simple ones, one-to-one. The inverse properties. If I take a to a power, a logarithmic power of x, basically what happens here is a to the log a, you can kind of think of it as canceling. So a to the log of a to the log of a, I'll get it right in a second. A to the log of x base a is equal to x. Also, if I take log of a to the x power base a, basically what's going to happen is log a base a cancels. And as we start doing problems, this will kind of make more sense. Okay. Okay, strategies for solving exponential logarithmic equations. Rewrite the original equation in a form that allows you to use the one-to-one property. If you can write it in the form of one-to-one, those are super, super easy to solve. Rewrite exponential equations in logarithmic form and apply the inverse property of logarithmic functions. Rewrite the logarithmic equation in exponential form and apply the inverse property. So there's two things to do, right? One-to-one, inverse. That's it. That's the only two things we're doing. One-to-one property or take the inverse. Some examples. If 2 to the x power equals 32, 32 happens to be a power of 2. I can rewrite 32 as 2 to the 5th power. Well, if 2 to the x power is equal to 32, then 2 to the x power is equal to 2 to the 5th, which means x equals 5, right? Natural log. If I have the natural log of x minus the natural log of 3 equals 0. Because I have two natural logs, what I want to do is try to get one of the natural logs on either side. I don't want two natural logs on the same side. So by adding natural log of 3 to both sides, I get natural log of x equals natural log of 3. Using the one-to-one property, x equals 3. 1/3 to the x power. How could I write 9 with a base of 1/3? Or could I change them both to base 3? 1/3 is 3 to the 4. 9 is 3 squared, which means negative x equals 2. But x isn't 2, right? Negative x is 2. Well, if negative x is 2, then x has to be negative 2. One-to-one property. Inverse properties. If I have an exponent that's a variable, if I want to bring that variable down, what I have to do is take the log of both sides. Now, sometimes when I say take the log, I'm implying natural log. Because the base in this problem is e, when I say log, what is the base that I need to be using? That would be e, which is natural log, okay? So if e to the x power is equal to 7, if I take the natural log of both sides, because that's the inverse of exponential, natural log of e basically cancels, giving me x equals natural log of 7. I did the inverse. I had an exponential. I needed to undo an exponential. I take the log of both sides. Part E, same way, right the opposite. I have a natural log. How do you unnatural log? Well, the inverse of log is exponential. So if I can turn both sides into exponents, it's kind of interesting. So what I'm doing is I'm going to choose some base. In this case, it's going to be e. I'll put an e right there and e right there. It gives me e to the natural log of x equals e to the negative third power. Why do you do that? Because e to the natural log cancels, giving me x equals e to the negative third power. What are y'all thinking about this so far? Okay. Any thoughts, insights? Nothing? Okay. So E, F, and G are basically the same. They're all logarithm problems. I'm using exponential on all three of them. The only difference is the base. Natural log is base e, so I'll put it e as my base on both sides and make what my original equation, if you will, exponents. Letter F, what is the base? Log x. What's the base? So because the base is 10, I just put 10 right there and 10 right there. 10 to the log x, 10 to the negative 1. And G, what's the base? Base is 3. So it's 3 to the log x, 3 to the 4th. Okay, questions so far? Okay, solve each equation and approximate the result to 3 decimal places if necessary. Letter A, what would y'all like to do with that one? Do you want to do one-to-one property or inverse? I'll give you a hint, not inverse.
It's the one-to-one.
One-to-one. Right. Okay. Notice these bases are the same. Well, if these bases are the same and they have exponents, don't the exponents have to equal each other? Okay. So for part A, this is one-to-one. I'm going to say that negative x squared equals negative 3x minus 4. What kind of an equation is that? A quadratic. How do I solve a quadratic? Quadratic formula, factoring, all these different tools we've got, right? First step is to write it in general form though, right? Adding x squared to both sides, I get 0 equals x squared minus 3x minus 4. Can you think of two numbers that multiply together give us negative 4, but when we combine them, we get negative 3? Negative 4 and 1, so this factors into x minus 4. There's my negative 4. X plus 1, there's my 1. So what does x equal? Okay. One thing that must be done here, you must check your answers. It is possible to get an extra solution. What is called? An extra solution is called extraneous. I gave you most of the word, right? So make sure you, and what do you plug them into? The original equation. Okay. So always plug them in for checking. I believe both of those answers work. I don't want to waste time with checking them. part B. Does that look like it's 1-to-1? Or does it look like we're going to have to use some kind of inverse operations? Any thoughts? Kind of hard to tell right now, isn't it? If you're trying to solve for x, what would be a good logical first step to solve this problem? Divide by 3. Divide both sides by 3, right? So if I divided both sides by 3, 2 to the x power equals 14. Can you write 14 as 2 to some power? No, 2 to the third power is 8 and 2 to the fourth power is 16, right? So I cannot do 1-to-1. This is going to have to be inverse. What kind of an equation is 2 to the x power equals 14? What kind of an equation is it? Where's the variable? It's exponential, right? This is exponential because the power is my exponent. What is the inverse of exponential? Log. Okay. To get that exponent down, I must take the log of both sides. What's my base that I'm working with in problem B? 2. This is my base. This is my power, right? So base 2, I'm going to take the log base 2 of both sides. What can I do to the left side? Log base 2 of 2 to the x power. Well, we're finding x. That's the whole problem that we're working on here. What was that property? The x. There was a property that said if I'm taking the log base a of a to some power, I can take the exponent and move it to the front. Now, what is log of 2 base 2? What is log of a base a? 1. Log of a base a is 1. So let me tell you the way I look at this. If I'm taking the log base 2 of 2 to the x power, in my mind, I see this right here. That's a 1. It's just going to cancel. What's now left on the left side? X. X equals log base 2 of 14. Now, this said solve each equation and approximate the results to 3 decimal places if necessary. We can do this one of 2 ways. I can either use change of base or I can use technology to figure out what is log base 2 of 14. Just for review, change of base. And remember, you can change to any base you want. And just because of mathematician laziness, writing natural log is easier than log because it's only 2 letters versus 3. I could actually write this as natural log of 14 divided by natural log of 2, right? The higher number goes on top, the base goes on bottom. If you key that in your calculator, what is natural log of 14 divided by natural log of 2? $3.807? Is that what you said? Okay, yeah. Yeah, so you can do it either way. You can either use technology and do log base, which is what math, and then up to A, right? Math up to A, enter, and you can put in the 2 and the 14. Okay. A is pretty straightforward. Give me any questions on B. Any questions on either of them, really? This is definitely new material for y'all. Okay, I'm going to go ahead and move on since there are no questions. There's the one problem worked out. There's the other problem worked out. And again, it's a good idea to check your answer in your original equation just to make sure you didn't do any computational errors. To solve a logarithmic equation, you can write it in exponential form. The natural log of x equals 3. What's the base when you're dealing with natural log? Natural log is base what? Common log is base 10. Natural log is base e. So what I can do, and you can see they've done it in the next step, is they turn natural log into an exponent, and they turn the 3 into the exponent. What base did they choose? E. Why E? Because that's the base of natural log. And just like I said a while ago, but a different situation, this is E to the natural log. Basically, that cancels. This is not 1-to-1. Yeah, from this point, yeah. Yeah, this is 1-to-1 going from here because natural log of x has to equal 3. Well, that's what you started with the problem, though. But that didn't help us. So we had to do inverse operation to get the x out. Okay. So x is equal to e to the third power. They call this exponentiating each side. You know, we multiply both sides by the same number. We divided both sides. We took the log of both sides. We exponentiated both sides. Okay. All right. Natural log of x equals 2. Let's solve it. What would y'all like to do? Exponentiate both sides? Make both sides exponents. What is my base? So e to the natural log of x equals e squared. How does that help me? Can't do 1-to-1. 1-to-1 would take us right back to where we started. Okay. E to the natural log is 1. So I have x equals e squared. Okay, part B. Log base 3 of 5x plus minus 1 is equal to log base 3 of x plus 7. Okay, we can cry. Good start. Now that we've dried the tears, next step. A dry cry because we're out of tears. Okay, great. Go to the store and buy a bottle of tears and put those in and see if you can cry. No. But let's. Okay, both sides are log base 3. What do we do? 1-to-1. Okay. The log base 3 of something is equal to log base 3 of something else, which means something must equal something else, right? I don't care what the base is on this. Okay. So we set those equal to each other, solve. Don't forget to check your answer. It's possible that algebraically you come up with an answer that doesn't work. It's possible for a problem to have no solution. Okay. Always check your answers. Questions on either one of these? Because we're only going to get more steps on problems. I'm not going to say harder because they're not harder. It's just more steps. You have a test over this. That's in the real world. Okay, part C. We have log base 6 of 3x plus 14 minus log base 6 of 5 is equal to log base 6 of 2x. So just cancel them. So you're wanting to say that 3x plus 4 minus 5 equals 2x?
Actually 3x plus 14 minus 5.
So you're wanting to say 3x plus 14 minus 5 is equal to 2x?
Yes.
No.
Because they share the log.
Yes. Yes. Can we rewrite the left side as a single log statement? Can't distribute. Cannot distribute a log.
It'd be 3x plus 14 minus 5.
How do I combine these? You're the only one that's got us in the right direction. I can combine the left side to one log statement. Okay, let's get us there.
So, like, from what I've seen is that in the parentheses of the 3x plus 4. Minus 5.
Okay, can't do that.
Yeah, exactly. So
I've got the difference of logs. The difference of logs is equal to the log of the quotient. Okay. A positive log goes on top. The negative log goes on bottom. I'm going to rewrite this in one statement. So log base 6. What goes on top? 3x plus 14. What goes on bottom? 5. Does this look familiar? Okay. The negative is what put the 5 on the bottom. The negative log, that thing went to the bottom. Okay. Now what? Now it's 1-to-1. Now it's clearly 1-to-1. I have a single log on the left side, a single log on the right side. So for this to be true, 3x plus 14 over 5 equals 2x.
Wait, for them to be 1-to-1, do they have to have the same, the log have to have the same base?
Absolutely. Yes.
Then it would have been 1-to-1.
Okay. Multiply both sides by 5. 3x plus 14 equals 10x. Next step. Subtract 3x from both sides. X equals. Don't forget, check your answer, make sure it works. Okay. I'm not spending any time checking answers because I think you're all capable of that. I'm going to delete the writing. Okay. You invest $500 at an annual interest rate of 6.75% compounded continuously. How long will it take you to double your money? Turn your microphone off.
That wasn't me.
Okay. What is the formula for continuous compounding? Huh? Okay.
Whoever Basin Durdick is who it was, 'cause I saw.
Okay. What for this problem? What is A going to be? No, I want to know how long it's going to take. I'm looking for T. What does A need to be? Why 1,000? Okay, A is after, right? So how much money do I have after? So to double my money, if I start with 500, then A is 1,000. P is, E is, E is E. R is 0.0675. T is? Okay, we don't know. That's what we're solving for. Okay. Let's get T by itself. What would you like to do first? Divide by 500. 2 equals e to the 0.0675 t. What kind of an equation is that? Exponential. I need to unexponential it. Inverse of exponential is log. What is my base? E. So what do I need to do to both sides? Take the natural log of both sides. So natural log of 2 equals natural log of e to the 0.0675 t. How does that help me?
Natural log.
Okay, so we can look at it as though this right here is canceling. So natural log of 2 is equal to 0.0675 t. Next step. Divide, yeah. So t equals natural log of 2 divided by 0.0675. That would be the exact answer, but that doesn't tell me anything. That means nothing. Okay, so using your handy dandy calculator, about how long is it going to take you to double your $500? What? Years. Okay, how hard was that? Just a formula, just a new concept. Okay, I'm going to go ahead and delete this. Okay, there's the equation.
Because he likes to talk math and we don't.
There's the work.
That's my favorite step. Using calculator.
Here's the graph of what it looks like.
Ooh.
And that's it for 5-4. Don't leave the meeting. I'll kick everybody out in one shot, please. Note to self is to turn off the chat feature.